Hi, today I've got an Egnater amplifier. This is a Egnater Renegade 65 in for repair valve amp. So I've been working on it, taking the top out. Basically none of the panel LEDs were lighting up, no sound, just the power light at the bottom was lighting up, but none of the panel was working. And so obviously I've taken it apart. Here we are. It's a very it's quite complicated for a valve amp. There's a lot of logic and all sorts of ICs in there, regulators. It's quite complex as far as valve amps go. Unfortunately, this is Egnater is I think the founder of Egnater is someone called Bob or Eric Egnater. I think it's Bob Egnater or something like that. Ben Egnater, sorry, Ben Egnater, I think it is. And he's American, but unfortunately this is made in China. So I noticed the brand of capacitors and things there are not the best. So that won't bode very well over time. Chinese capacitors have a tendency to only last, I don't know, 1,000, 2,000 hours, their active life of use. Whereas if you get a Japanese capacitor like a Nippon Chemical, that has a lifetime of 90,000 to 100,000 hours, so much different. Also sound quality of, if any audio passes through these electrolytics, sound quality is bound to be better on a better capacitor, like a Nishikon. Even a Panasonic. Are a good make of capacitor as well, but these here, I'm not sure what these are branded, but they don't look that great. Anyway, when this came in with a faulty panel, I actually found a couple of fuses blown. F1 and F2 were blown. Also, this capacitor here was slightly blown as well. As you can see, the top is slightly domed, and this base you can't really see that very well, but that was slightly domed as well. So that indicates, because this is you can download the diagram for this schematic quite freely. This is on the input circuit, so it looks like it's either received a spike on the input, or it's been switched on very quickly on 220 volts, and this is a 127 volt setting. In fact, this is 117. 100, 117, 230. Obviously 117 is not the same as 127, which they have in Brazil, but it probably should be okay, reasonably okay. So anyway, this mess here of wires is the power supply. It's very difficult to get out to replace components on there, because you know some of these wires go into the board, into the mains transformer through a hole in the board. It's a nightmare really to take apart this, really. But there we are. So the first thing you would do in repairing this is obviously to check all of the connections, all of the fuses, do a visual inspection and see whether anything is burnt out. In this case, nothing was burnt out, just this capacitor was bowled up. So I thought, great, replace the fuses, replace the capacitor, and see what happens. So I did that, and bingo, the panel lit up again. But my safety lamp here came up brightly. So I thought, right, so I taken all the valves out. There's two 6L6s in here and two EL34s. That's the output. They're the output tubes. You can blend 6L6 and EL34s. There's a knob there to blend which one is more dominant. The 6L6 is a higher output and provides more distortion, whereas the EL34 is more natural. That's the sort of valves that are used in hi-fi amplifiers. As you can see, you have 4 power diodes here. Each one is marked, so I know the original position. I marked the plinth and I marked the valve, so I know which position each valve goes. And these are the 5 screens. There should be another one somewhere as well. Yeah, sorry, there's one more here. There's 6 12AX7s in there, 2 EL34s and 2 6L6s in here. Anyway, once I put all the valves in and switched it on, my lights lit up quite very brightly, in fact, so that shows that there's some sort of dead short there. So now I've taken all the valves out, make sure there's not a valve shorted, and there we are. It's lighting up quite brightly, then going dimly. It shouldn't really be going dimly at all because there's not a single valve in there. All the valves have been taken out. They've all been taken out there, you see. It shouldn't really be lighting up at all. Perhaps there's a problem maybe on the output transformer. What you would do when you repair these valves is you would pull off all of these leads which are coming from the secondary of the transformer. Blue, that's these blue wires, they come, they're the low voltage side, 12 volts, plus or minus 12 volts is the blue. These here that are disappearing down here, the orange, yellow and green and black, they're going to the output transformer, and there we have him on that board there. So if you suspect the output transformer might be a bit dodgy, you can disconnect those. These green here, I think are something to do with the heater, and that is quite a common problem. Someone's been in here before, they've marked VD, which is Portuguese verde, which is green. Obviously the board is marked green on there as well, so I can understand the original name. Green and yellow. So you would disconnect this bunch here and see whether, let's disconnect it now. So if I disconnect these, just pull them out. Right, but there's no valves in there anyway. There might be some sort of problem in the heater circuit. Let's see. No, that's still lighting up. So what you would do is you would, the yellows I think are high tension circuit, but as I say, there's no valves in there. Obviously the very first thing you would do is check all the fuses. All the fuses have been checked in this. All the fuses are fine. I've checked them. What you need to do with these fuses is you need to pull them out to test them, because sometimes if they're across a resistance, like for example a transformer, then they'll appear to be okay, intact, because of the resistance of the transformer. But when you pull them out, you'll find they're open, so you need to pull them out in order to test them. This board here is the board that has all the smaller 12AX7s in, and this obviously here is are the output valves. 6L6 is marked there, EL34's here, and this final one here is actually a 12AX7. It's inverter valve, so the signal comes in inverted. It's because after these 5 valves here, the signal ends up being inverted, so you have to invert it back to the normal way, back in, this is non-inverted. This will take the inversion out that's caused by these 5 valves. Every valve stage the signal passes through, the signal will invert by 90 degrees. So 90, 180 degrees. So you have to keep, unless you want the output to be inverted, which you don't really, you need to keep inverting it, re-inverting it. So you end up with the same phase as the original input that you have. You don't want it output out of phase with the input. So yeah, I mean, you have reds connected down here, the greens, whites, yellows, blues. You just need to disconnect them and just see when this light goes out. At the moment, I've disconnected pretty much all of them. The light's still not going off, so that would say that there is a problem possibly with the mains transformer. So I need to test that. That's quite serious generally, mains transformer problems. In many countries it's extremely serious because you have to try and get the original transformer, and they're quite expensive really. But in Brazil it's not so bad because I know someone here in Brazil that takes the transformers apart and redoes the wiring of them. We call it enrolamento. That is where he takes the windings off and rewinds them. So that's pretty good to know someone who can do that. I also know people that can refurbish. There's plenty that can refurbish speakers here. Rewind the bobbin, replace the burnt bobbin. So that's useful really. In Brazil, people don't tend to throw stuff away because things are so expensive here to buy in the first place. This Egnater amp must have cost a lot of money. Although I've had a few Mesabugis through here, and I've had Mesabugi and Carvin. I was very impressed with the Carvin, the layout and the components used in it. This is Chinese though, which is unfortunate, and it shows. You have all the marks here, the quality marks you usually get with Chinese stuff. I mean, I don't like the way this is wired. It's overcomplicated for what it is really. It's a valve amp. Valve amps are supposed to be less complicated, but this has got wires all over the place, rails all over the place. Anyway, this is my battle for today. I've got all the valves safely there. As I say, I've removed all the valves. I've removed all of these cables, and it's still got some sort of short circuit on there. So the next thing I'm going to do is remove this for the output transformer and see whether the light disappears. I doubt whether it will actually, but we'll try. Remove this, and maybe there's still more problems on the main power supply, which will be a real pain to get out. But you know, you have to do what you have to do. You know, it's going to be probably the best part of a day's job to sort this out. So it is what it is. There we go. So anyway, hope you found this video interesting. And this is going to be a long job, a good job. Okay. Thanks very much for watching.